everybody. Welcome to Chemistry with Miss E. We are going to talk about two words that both start with an I and could sound familiar but are completely different and very, very important to know as you continue your chemistry foundation. We've got ions and isotopes. Specifically in this video, I'm going to talk about ions, and then I'll do my next video on isotopes just to make sure that we can really get into the good examples and understanding the difference between the two. I want to talk about this topic here on if you change the number of, because it's going to be a lot of words thrown at you, and if you can keep this concept at the forefront of what you're doing when you're doing atoms, ions, isotopes, then it's going to help you out a lot. If you change the number of protons for an element, then you have gotten yourself a new element, okay? Remember, if you remember my last video, protons are the identity of an element, okay? Nobody else, for example, on planet Earth, right? No other element can have one proton. Only hydrogen can have that. Same thing with boron, right? No other element can have 5 protons. Only boron can have that. So if you change the number of protons, you're working with a completely new element. And that's really not necessarily what we're looking about here in this ion and isotope idea. Now, if you change the number of neutrons, you've got yourself a vocab word. You have made an isotope, okay? So when you change the number of neutrons, you have gotten yourself an isotope. And this is when the mass is going to be different. This is because neutrons are responsible for the mass of an atom for the most part. Again, you're still working with the same element, okay? So for example, I would have boron, right? But I have different versions of boron, right? Based on the mass. So when you change the number of neutrons, you get an isotope. And my next video will be on that. Electrons, this is the one we're going to focus on here in this video, and it's very, very important. This is when you get an ion, okay? And when you think of ion, I tell my students you should immediately think of charge, okay? Ion, charge, every single time. And that happens when the protons, which are positive, do not equal the number of electrons, which are negative. And so when you have positive and negative not matching each other, you have an offset, you have a balance, you have a charge there, okay? Whether that's positive or negative, we'll look at that, but you do have a charge. So if you change the number of electrons, you have yourself an ion, and that's what we're going to really understand here today. So continuing into the ions idea, that means I have changed the number of electrons, okay? That means the protons do not equal the number of electrons. When you have a cation, this is not cation, okay? A lot of students might say cation, it's a cation. I want you to always think of that root word ion. Look at that, ion. When you think of ion, what should you think of? Charge, okay? Same thing here, you have anion. So these are the two forms of ions that exist. A cation is when you have a positively charged ion, okay? It's positively charged. And this means you lost electrons or gained electrons. And think about it, don't answer too quick. Because electrons are negative. This is super important, okay? Electrons are negative. So think about this. If an element gains electrons, they're gaining negative particles, right? So they're going to be more negative. If an element loses electrons, then they are losing negativity. So the ion itself is going to be positive, okay? So if it's positively charged, that is a cation, that means it lost electrons, okay? 1 electron, 2 electrons, 3 electrons, we'll know, but that's a cation when they lose electrons. An anion is going to be negatively charged, okay? And that's when you can obviously think of the opposite, but if I want to be negatively charged, then you need to gain electrons, okay? So an element needs to gain electrons in for it to become a negatively charged ion, aka an anion, all right? Now let's do some quick little memorization rules, some little tips and tricks to help you memorize it. For the cation, I want you to extend that T up real high and make a positive sign, okay? Just reminding yourself that this is a positively charged ion. Anions, right, you have AN, that prefix usually in the English language means something negative, right, like annihilate, annex, so it's like a negatively charged idea. And so it's just a little tips and tricks to help remember the difference between the two. Now, let's continue on into how you apply this to a problem and something that you are probably going to be asked, okay? So we're going to be listing ions on this side, and they're going to be given to you. And then you're going to be asked something along the lines of how many protons does this ion have and how many electrons does this ion have. You could also be asked neutrons, but I'm not going to focus on that for right now. So let's look at Ca2+. The first thing I want to talk about, Ca, this is standing for calcium. And the +2 is telling me that this is an ion, okay? That means the protons do not equal the number of electrons, okay? So calcium plus 2. Is this a cation or is it an anion, right? It's a cation because it's positively charged, right? It's a positive charge. So that means that this lost electrons. And how many to be exact? It lost 2 electrons, okay? Because of the plus 2 sign. So here's how you apply it, okay? I go to calcium on the periodic table. I see it's right here. Calcium has an atomic number of 20. That means it has 20 protons. Again, it doesn't matter that it's an ion. Calcium has 20 protons, always and forever. That is the identity of a substance. That doesn't change. Electrons, though, if this atom were neutral, it would have 20 electrons as well. But we know it doesn't because it has a plus 2 charge. So if calcium is a plus 2 charge, lost 2 electrons, and normally it would have had 20, then I need to do 20 minus 2, and that will give me 18 electrons, okay? Let's try another one. Let's do nitrogen as a negative 3 charge, okay? So N minus 3. Again, they're giving a charge right off the bat. You know this is an ion. You need to account for that ion and understand what it means. Nitrogen on the periodic table has an atomic number of 7. So that is how many protons it has. Now again, neutrally, it would have 7 electrons as well. However, this is not neutral. This is a negative 3 ion charge. That is an anion, which means it gained 3 electrons, okay? So instead of 7 protons, right, or I'm sorry, instead of 7 electrons for it to be neutral, you need to do 7 plus 3 electrons. So that would give you 10, all right? 10 electrons. Let's do another one, and I'll show you here. Let's do Na plus 1, okay? Na plus 1. So again, find Na on the periodic table. Over here on the left-hand side, it has an atomic number of 11. So it will have 11 protons. If it were neutral, it would have 11 electrons as well. But this is not neutral. It has a plus 1 charge. That means it has a cation, right? It is a positive charge, which means it lost 1 electron. So 11 minus 1 is giving you 10. Now you're going to start to notice an 18, a 10, a 10. You're going to notice a trend here with the electrons and the ions. That's for periodic trends down the road. But there you go. That is cations and anions and how to interpret them and figure out the electron count when you're given an ion charge. I'll see you on the next one. Bye.